Hello, my name is Jeremy Shearer. I'm a Senior Partner Solution Architect here at AWS. I'm part of the Oracle Applications on AWS team, and my focus is to help partners and customers successfully migrate JDE workloads to AWS. Today, I'm going to talk with you about how to architect a SQL Server database to support the unique I/O characteristics and the performance characteristics of JD Edwards. I'm not going to delve into resiliency configurations and some of the other requirements of these solutions. I'm going to save those for another session. Today we're going to focus very tightly on the performance characteristics and how to architect for those characteristics. So when JD Edwards uses a SQL Server database, it has unique characteristics. And one of those is the way that it interacts with the database is it sends only basic data manipulation language commands to the database to read and write the data. And it typically does those in a sequential order where it'll do one after the other. It won't do a fire hose where it sends a lot of requests at once. It'll do these queries one after the other. The impact of that is that we don't use a lot of CPU on the database itself because most of the processing is happening in the application tier. But what we are very sensitive to is the I/O characteristics. So one of our first requirements then is we need to architect a solution that has a low amount of CPU horsepower, but a lot of I/O capability with it to meet what we need for JD Edwards. The second characteristic that we have to architect for is the read latency sensitivity. So because JD Edwards is doing a lot of these operations sequentially, one after the other, the time it takes to perform any one of these operations accumulates as we're doing hundreds of thousands of them sequentially. So we need to minimize that latency on those read IOs. Next, we have to minimize the read latency for our write IOs, particularly to our log files. So we have processes like JD Edwards MRP that are doing these sequential write operations, and the time it takes to do the write directly impacts the runtime of the processes. And finally, we need to architect an understanding that we use read committed snapshot isolation, which I'll talk about a little bit more in detail here in a few minutes, where it creates a lot of I/O in our TempDB database. So we'll need to architect a solution to accommodate that. So let's start by talking about our EC2 instance type. Our go-to instance type for a JD Edwards SQL Server database today is our X2 IEDN instance type, which provides a lot of I/O backend for each vCPU that is provisioned. Additionally, it provides a lot of RAM for each vCPU provision. It gives us 32 gigabyte of RAM per vCPU. And what that means to us is that we can allocate that RAM as a SQL Server, as a SQL Server buffer cache into our SQL Server database. So we got our JDE database here. And any time that we can use that RAM for the buffer cache, we can return the data very quickly. We don't have to go to disk to do it. So we're trying to get out here to our application tier, get our data back to the application as quick as we can. When we get that data from memory back to the app, that gives us the lowest read latency sensitivity. So we want to pull as much as we can from that memory. We want to get a very high buffer cache hit ratio. 99%, 99.5%, 99.9%, those are great ratios. We want to be up there as high as we can. Even when we have those high ratios, inevitably we're still going to end up having to go to disk. And to come to disk, we'll typically use our GP3 storage, our GP3 general purpose 3 storage. Each one of these volumes can provide up to 16,000 IOPS of performance with a moderate amount of latency. These are SSD-based drives. The latency is pretty good on it. If the 16,000 IOPS is not enough performance, we can actually stripe and mirror across multiple GP3 volumes. So if we use 4 GP3 volumes, that'll add up to, you know, up to 64,000 IOPS of throughput there. So that covers our read latency requirement and our read IO requirement. But what about our write IO requirement? Most JDE processes can also put their log files, their LDF files, also on GP3. But if you're running some very time-sensitive processes that are very write-chatty, like JD Edwards MRP, you may need to move the log file to our low latency IO2 block express storage. So this IO2 block express storage provides sub-millisecond latency for these write operations. So we have seen, you know, hands-on when we move the LDF file of the SQL Server database from GP3 to IO2, we've seen the runtime of the MRP process drop in half by making that move. So again, we put our data, you know, MDF and LDF files on the GP3 storage, and our log files, our LDF, on our IO2 block express. So now we've covered our point 1 about our low CPU to IO. We've talked about our read latency requirements. And we've talked about our write latency requirements. But what about our TempDB? Well, our X2 Instance Type up here has a neat feature with it called an instance store. So these instance stores, which we can have up to 1.9 terabyte per instance store with up to 2 of these instance stores per server, are ideal for our TempDB IO requirements. So the way that we would leverage these instance stores is we would actually move our TempDB out here to these instance store locations. These instance stores are ephemeral, which means when this system is shut down, the content of these drives, you know, goes away. So that's perfectly acceptable for our TempDB database, because when when SQL Server restarts, it recreates this TempDB database with every restart, just like we recreate and repartition these instance stores every time our EC2 instance restarts. These instance stores provide very high IOPS, very low latency, and it, you know, very nicely meets the requirement, or number 4 requirement up here, of the heavy TempDB IO requirements when we have that RCSI enabled. So just real quick in summary, we talked about the unique requirements of running JD Edwards on a SQL Server, where we need very low CPU to IO ratios. We are very read latency sensitive, so we want to have a lot of buffer cache, and we want to have moderate latency, you know, out to the storage. We talked about write latency sensitivity, particularly for jobs like MRP, where GP3 is typically enough, but sometimes we actually have to move to even lower latency IO2 block express for our log file. And then we talked about the heavy TempDB IO with our CSI, where we can move that out to our instance store. Thank you for attending the session today. I hope you have a great day.